Hello, everyone, and welcome to this first webinar in the ARC Incubator Program webinar series. I'm Nicholas Olberning. I am a statistician working with the ARC Network, and I have the pleasure today of leading our first webinar titled The Introduction to the ARC Database. And so just to orient us all again, the Acute Rheumatic Fever Collaborative Network aims to discover and validate acute rheumatic fever biomarkers that could become a diagnostic test fit for purpose in RHD endemic settings. And the Clinical Recruitment Corps does support these efforts through the global recruitment of acute rheumatic fever cases and controls. And this work really does present us the very unique opportunity to conduct high-quality clinical and epidemiologic research on acute rheumatic fever globally. And really this is an area that has been neglected over the past few decades. And the ARC Incubator Program, born out of discussions that we held at the first ARC retreat in Abu Dhabi, aims to support the careers of early stage ARC investigators in conducting research and generating high quality publications that can help advance our contemporary understanding of acute rheumatic fever. And so the incubator will consist of 4 modules, and these are aimed at supporting investigators towards developing a scientific presentation and a publication by mid-2025. And as you've seen in the materials that have been sent out previously, we have outlined some responsibilities and deliverables both by the Corps and the investigators to help keep this endeavor on track. And so the Corps, our responsibilities will be to deliver educational webinars like the one you're listening to now, as well as to provide feedback on the site-specific deliverables. And the investigators, the responsibilities will include the submission of these module-specific materials and deliverables, which I'll cover over the next few slides. And here I'm giving you an overview of the incubator modules that we have planned to date. We have modules planned to cover aspects of data elements and the ARC database, conducting a literature review, a primer on research methods, as well as a session on data analytics. And so for this first module on data elements, which we are conducting today, I'm going to cover aspects of data quality and the importance of data quality and data collection. I'm going to talk a little bit about the ARC database and the REDCap data dictionary that you will be working from, and a bit about how we can create shell tables that will help guide our manuscript and our analysis. And so some of the investigator responsibilities after this first webinar are to identify the data elements from the ARC database that you will use for your research project. And then to generate some shelf tables that may serve as the results template for your publication. Our next webinar that's lined up is going to be about finding and documenting research in your field, where you will go over how we develop a sample annotated bibliography. And then you'll have the opportunity to go out and generate a draft bibliography using the Zotero software. Later on, I will provide a webinar focused on understanding research methods and drafting a method section of a manuscript, where I'll focus largely on, what are some of those aspects that we like to include or are commonly included in the methods section of a paper, as well as covering the STROBE guidelines for reporting of observational data and how we can actually use those guidelines to inform the design and the drafting of our methods section. And then you will have the opportunity to go out and actually draft the method section of your manuscript. And then our final seminar is going to be on quantitative data analysis and drafting results, where I'll talk a little bit about basic statistics, interpreting results, and drafting a statistical analysis plan and stats section. And then we'll work together to actually draft and outline an analysis plan for your specific study. And then once the analyses are complete, we will assist in the interpretation of those results. And so when talking about data quality, I often like to begin a session like this with this rhetorical question about, why do we care about data quality, right? So why is this an important topic that warrants, our attention? And it really boils down to the fact that low quality data can contribute to incorrect study conclusions. It can erode trust in medical research, and it can ultimately lead to poor public health policies and medical interventions that are based upon inferences made from poor or low quality data. When we're conducting clinical studies, low quality data can actually directly impact the safety of our patients in our study. So this really is a key concern and something we want to be incredibly diligent about, right? We want to ensure that we are using approaches and methods to collect data in a way that is high quality, rigorous, and reproducible. Specifically in clinical or epidemiologic research studies, low quality data can introduce bias, right? One example of this is that low quality data can lead to the misclassification of our exposures and our outcomes. For instance, if our data collection is so poor, we can sometimes actually misclassify the exposure status of a given patient, right? And so when we do this often, or it can lead to challenges such as bias that may lead us to making the wrong inferences in our study, right? We may come to the wrong conclusion because we collected either the wrong or low or poor quality data elements. This can also lead to measurement error, which can reduce our statistical power, and it does make it harder to observe true associations, right? So in the instance where the data quality collection is so poor, it doesn't necessarily bias our results. It can still add noise that can complicate the analysis of our data. And so here is just a quick list of some of the things we have actually implemented in the ARC network to ensure we are collecting high quality data. So we have taken the time to develop detailed protocols that actually document our data collection, data storage, and data analysis steps. We have conducted uniform training at each site that many of you have been partner in and have partaken in. We have conducted and generated standardized data collection and case report forms, right? So we're using standardized CRFs for which we will collect the data elements. We are performing steps in the background, right? Data cleaning steps where we have expert adjudication of acute rheumatic fever diagnosis, for instance, as well as once this data hit our database, on the back end, we have clinical records that are being checked for completeness and are being quality controlled, as well as the data are uploaded to the ARC REDCap electronic database where data quality checks are occurring, logic checks are being done, and regular reports are being generated, right? So there's kind of a multi-pronged strategy here to make sure that we are uniformly collecting these data elements that we think are going to be critical to our research efforts. We're making sure that those are being input in a uniform manner and consistently over time. And then once those data hit the database, we're taking steps to make sure that those data elements make sense, that they meet the logic parameters that have been implemented, right? For instance, the age is within the expected age range, and we are regularly generating these reports, to stay on top of these aspects to identify any problems in as close to real time as possible so we can make the required adjustments. The ARC network data is housed in what is known as a REDCap database. So REDCap, which stands for Research Electronic Data Capture, is a secure web platform for building and managing online databases and surveys. This is a very popular database software that was developed at Vanderbilt University here in the US quite some time ago. It has over 3 million users across 155 countries to date, and has actually been cited in over 36,000 journal articles. So this is used by many teams in many countries to conduct high quality and efficient research. We like it for many reasons. Some of those here are that it is free for use to nonprofits. It is very easy to use, and there's great documentation for users, and a growing and I think motivated research community that contributes to the REDCap infrastructure. It really does streamline the process for designing databases. It's very efficient and very flexible for that purpose. You can generate custom reports within the software, which is very nice. And it is very easy to export the data from the database on the back end to allow for statistical analysis. And so our ARC database, as of current, has about 600 records and 850 fields, right? So this is as of February 1st. So this is a very large database, right? If you were to pull this down into a spreadsheet, for instance, it would be about 500,000 cells and growing. And so this is something we maintain at the Clinical Coordinating Center. And you as ARC investigators should never really have to directly interact with the database. But I do want to very quickly just show you what we see on our end. Here's an example of what we see on our end when we look at the ARC network database. Once we log in through our two-factor secure authentication process, it brings us to this landing page. And as you can see here, we have the title of the database, we have information on current users, the project statistics, right? How many records are in the project, how much space it's actually taking up, if we have any upcoming, scheduled calendar events that we might have set for ourselves. But most of the functionality that we use is on the left-hand side here. And so you can see how you can operate through your project homepage. The code book I've highlighted in red. This is what we're going to be talking about next, and what will be most useful for you for identifying your data elements and for building your shell tables. But there's also a ton of other functionality that REDCap can do, and a lot of it is accessible through these point-and-click interface options. And so if you have any interest in REDCap, please reach out to me or other members of the team, and we're happy to talk to you a little bit more about REDCap, maybe how you can gain access, how you can use it, where training modules exist. Because again, I think it's a very flexible and very user-friendly database system that we use here at Cincinnati Children's Often, as well as do many research teams around the world. Okay, so I want to touch briefly upon this REDCap data dictionary and code book, because I do think this is going to be the most important document to help you identify those data elements that you need and to put together your shell tables. So what we will have provided by the time you're viewing this webinar is the full code book from our database. So this is a pretty large document. It's got over 800 variables spread out over 75 pages of text. The good news is that those pages are separated out into sections that increase the ease of use. So, there'll be sections on, let's say, demographics, on things like medical history, on things like risk factors. So if you know what you're looking for, you can kind of move to those subheadings and kind of operate through the document in a more efficient way. I use these a lot. A lot of times I'll come into a project where I didn't build the database, so what I am operating with is the code book. So I'm often in a position very similar to the one that you will be in soon. And what helps me most is just using the search function through the PDF. So, I'm on a Mac. For me, it's Command F. And then I just start typing in, something like age, if I'm interested in finding the age of a patient at the time of enrollment. I see what lights up, where my hits are, and then that kind of leads me to what I find. So again, I use this often, and for me, it really is the search functionality that really helps speed up the process after I usually do a first kind of skim of the whole document. And I'll show you an example on the next slide here. But what you'll see when we get there are three main columns in the REDCap data dictionary. The first is the variable or the field name. This is just the variable name. So this is a short, informative variable name that is used for the analysis. This is something that will be most helpful to us at the DCC as opposed to you as an investigator. The field label, I think, will be most helpful to you. This is a longer form description of the variable as you would see on a data entry form or a survey, right? So this is a more descriptive explanation of what that variable is that's being collected and being identified by that variable name. And then the last column you'll see is what's known as a field attribute in REDCap. All this is the type of data that's being collected, right? So it'll tell you in the code book if the variable you're collecting is a text field, if it's a drop down, if it's a yes or no column, if it's some type of calculated field, all that information as well as the possible options in some cases are given. So here we're looking at a short section of three variables from the demographics section. And so this is exactly what you will see in the PDF document. And here you can see we have three variables. We have country of site, date of birth, and age. And so in the first column for item 14, which is country of site, we can see that that is the variable name. We then have the descriptive variable label, country of study site, and we have the attribute. So here we can see that that attribute is a drop-down. It is a required element, and you can select one of the four options. Item 15 here is date of birth. We can see that in the variable name or the field name. The label is year of birth, right? So you can see we are being a bit more descriptive in that label than we can in the variable name. And some of these variable labels will be much more descriptive, right? They may be, a sentence or more actually describing what's being collected by that variable name. And here we can see that it is a text field, and that is an integer that has these required minimum and maximum values, right? So it is going to be an integer valued variable that has to be within 2003 to 2024, right? We've restricted the data range to those points. And then, item 16 is age is the variable. The label is age in years. And again, we can see that the data that are going to be available to us on the back end are going to be text data. It's going to be an integer, and we are only allowing entry of patient ages between 3 and 18 years of age, right? So that is a data quality aspect that I mentioned before, in that we require the values to fit into this pre-specified range. So if you try to put in a patient who is 180 years of age, which we know would be a data entry error, but very easy to do if you accidentally thumb the 0 on accident on your keyboard, right? The built-in logic would stop that data entry error from happening. And so I wanted to quickly dive a little deeper into some of the variable types that you'll see in general and in the REDCap data dictionary. So anyone who's taken a first course in statistics or data management or quantitative research methods has probably come across this NOIR measurement scale, right? This is a very popular way to think about variables. I think it was developed back in the 1940s by a psychologist at Harvard who came to the realization that any type of data that you probably come across, quantitative data, can be categorized into these four groups. And so these are nominal, ordinal, interval, and ratio, right? So Noir is a good way to try to remember that these names. So what are nominal variables? Nominal variables are essentially our most simple type of variable. This refers to just variables that are mutually exclusive groups that have no order or specific structure to them, right? So the classic example of a nominal variable is just male or female, right? We have these two mutually exclusive categories that don't have any underlying, let's say, numeric importance. Often we will recode these to, let's say, 0 and 1. So we may create a new variable, female, where female equals 1, not female equals 0. But again, that is still, nominal information. Ordinal variables carry a little more information. These are variables whose values can be ranked, but the distances between each rank are not necessarily equal, right? This is kind of the defining characteristic of an ordinal variable. And really the classic example is a Likert item ranking. And so those of you who have worked with Likert data, often they're just scored maybe 1 to 5 or, more to less in terms of, let's say, your satisfaction with your most recent purchase, where they have a clear ordering, right? Like 5 is higher than 1, but the distance between 1 and 2 might not truly be the same as the distance between, let's say, 4 and 5, right? So that is the quintessential nature of the ordinal variable. Interval data, again, can carry a little more information. These are variables whose values can be ranked, and they have equal distances between those intervals, right? So that sets them apart from the ordinal data. But one caveat here is that they have no true zero value, right? So for instance, temperature in degrees Celsius is kind of the classic example of an interval data, right? We know a value of 5 is lower than a value of 10, right? We know it's going to be colder, and we know that the difference between 5 and 6 and 6 and 7 are the same distance. But again, we don't have a true zero here in the fact that 0 means the absence of information, right? Or an absolute 0, I guess is the way I should describe it. 0 is freezing, it's not a true 0, right? And then ratio information, again, carries the most information. Here, our values can be ranked. They have equal distances between each interval, and they do have an absolute 0. Lots of examples here. The one you'll commonly see is income. For instance, let's think of income in US dollars, where here this is a continuous numeric value where the ranks are important, the ranks are equally spaced. And if you have a value of 0, right, that means you're stating that I have no income, and the 0 in that case has a very specific meaning as an absolute 0. Now in REDCap, the variable types are slightly different. REDCap doesn't follow exactly, at least in terminology, the Noir nomenclature that I just presented. Instead, they use text fields, checkbox, drop-down, other types of variable attribute names. But of course, anything other than free text can be mapped directly back to this, again, Noir nomenclature, which is very helpful, I think, in thinking about the type of data you're actually going to get from a given variable, right? Is it going to be nominal? Is it going to be ordinal or ratio scale, for instance? And in particular, that's a critical piece of information to help inform how we might actually analyze that data, right? So knowing the type of data is important to think about, how we might best carry out a statistical analysis. In REDCap, some of the fields you're going to see as you look through this data dictionary, probably the most common is going to be listed as a text field. And text fields in REDCap have and can have various meanings. So, I think we would most associate this with a free text field. This is any character string represents a valid variable type. So for instance, you might, in the database, what we might actually see for an open free text field is a person could go in and type, patient had symptom X, or you could enter a alphanumeric subject ID, for instance, using a free text field, where you could have something like F001 could be entered as free text. And you can also put constraints on that as well. Probably, most commonly for many of these are going to be numeric text fields, which again, in my mind, is a bit of a strange naming convention. I like to use the words text to refer to character strings and numeric to refer to numbers. But unfortunately in REDCap, that is not the case. So text fields can be numeric, and they can be numeric text. And this can really be of any type. It can be interval or ratio values, and it may have field restrictions as I showed you before. So for instance, you might see age. Age might be listed as a text field, and it's a numeric text field. And on the back end for a given patient, what we might see is the age is 10.52 years when rounded to the second decimal place. And again, there could be restrictions on that, and those are set by the database developers as they build those fields. But just be cognizant that in REDCap, numeric values can be referred to as text fields. Dates can also be text, and so you'll see that as well when you look through your data dictionary. And so you'll see date entered as text. Usually it is date underscore month, day, year, something along those lines. And again, in the back end, we'll just have the dates in the database. Checkboxes are very common. You'll see those. Those are, I think, very intuitive. That is just a variable where you're restricted to a set of given objects or elements to select from, right? So you'll have a checkbox, and your drop downs are A, B, and C, right? And so you have to select either A, B, and C. If it's a required field, those will be guaranteed to be entered. If it's not required, then it can be left blank. And then I think the third variable type you're going to see the most of in REDCap is this yes/no field. And so here, I think it's very intuitive. Your options are yes or no. And then you'll see this listed in the data dictionary as yes, no, and that'll correspond to either a 0, 1 or a 1 and 2. And we can convert that back to numeric values. And so probably the most important slide here, or I think the key takeaway message is, how do we map data elements to your research question? And I've got a few thoughts here. Hopefully it is helpful advice, but certainly please reach out to us if you have questions, after reviewing the data dictionary as to how you might best go about it. But for me, everything starts with a clear and focused research question, right? So if I know exactly the research question I want to try to answer, and I've articulated that in a sufficiently clear manner, well, then it is often, I think, much easier to go back and identify those data elements that I need to answer those research questions. And so that's the second point here, is to then, once you have a research question, consider the key variables required to answer that question. And here, I always like to think about my primary as well as my secondary exposures. So what are my exposures of interest in my study? What are the primary and secondary outcomes that I'm interested in examining? What key covariates might I need to include for any type of, let's say, statistical adjustment, or perhaps any subgroup analyses, right? So if I have a specific question of interest, and I'm interested how that differs between, let's say, male and female participants, then I want to be sure that I include, a variable on sex in my list of data elements to obtain from the database. And then any other variables required to describe the study population, right? And so here I think about, what type of information would I like to include, let's say, in a table 1 of a manuscript to help describe the study population that we're examining, right? So if you think about those kind of 4 key aspects, I think that'll go a long way in to helping you identify which variable names, or I should say which data elements you want to obtain for your study, and then map those back to the variable names. Again, probably the REDCap Data Dictionary field label is going to be the most informative way for you to do that. And so then, as I just mentioned, you'll go ahead and take the REDCap Data Dictionary and identify those variables. And then we will help to confirm that data has in fact been collected and it includes all the information that you need. Right? So sometimes you can run into the case. We hope not here, certainly with the ARC network, but I have been involved in studies where you may identify a data element, it's important, you think you have it in the data dictionary, but you go back and look and it's not there, right? So that's frustrating. Or sometimes you may have a variable that's there, but not all the information that you might need for your specific question has been collected, right? The data collected may not be specific enough for your research question. And so that's what we want to help make sure that we have. And then once we've got all that, we're going to go ahead and take that information and we're going to put them into some shell tables and build those out for the paper. So what is a shell table? So for those of you who have never worked through shell tables or have been introduced to shell tables before, it is simply just a table without the results or the values filled in, right? So it is literally just an empty table that you might envision existing in your future manuscript, right? So it gives us a guide as to what tables we might want to include in our manuscript, and specifically what information do we think is important to include and to convey to readers of that paper. And so, thinking big picture here, why do we create shell tables? Well, to help you think about what results you will present and how you will actually display them. They help you think about what variables you will need to collect. They help you communicate to the team, your research team, what specific areas, right, are we really going to focus this paper on? They help you work with your statistician to help develop your statistical analysis plan, right? The more that we know about what type of results you want to present and how you might envision presenting them, that might help us structure the way in which we approach this analysis. And certainly once you have that structure in place, they help you write up the results of your manuscript. So we use shell tables all the time in our projects, especially when working with trainees, our new investigators, the development of a study protocol, and then the development of shell tables are typically our, number 1 and number 2 activities. So to help make this a little bit more concrete, I want to run through a few mock or example shell tables here, just so you can get kind of a feel for what this might look like. And I decided to kind of break this out into the different types of tables you might see in a manuscript, whether or not it's a table highlighting univariate associations, bivariate associations, or maybe what you might present for, let's say, a multivariable regression model. So here's our first example. So this is an example shell table if we want to present univariate statistics for some given set of variables. And this is kind of course, our most simple example. Here I'm showing you where we could lay this out, or how you could lay out your shell table for like a table 1. Let's say if you didn't want to compare any 2 groups, but we just wanted to kind of report the demographic and clinical characteristics of our study or our patient population. So how I like to do this is in the first column to give a descriptive label. So this is essentially going to be what a reader would see in a published manuscript. This is probably going to be very close to what you'll see in the field label for the REDCap Beta Dictionary, right? This is a more descriptive explanation for what a given variable is. Then in the second column, we like you to provide the actual variable field name. This will make it into the actual paper, but for us at the Data Coordinating Center and for the statisticians, this is extremely helpful to help us identify those variables that will map to these tables, right? So if you just give us distance to the nearest health center, then we have to go back into the data dictionary and try to guess at what those variables might be. And here is probably pretty straightforward, but there are other variables and other situations for where there may be some ambiguity, right? We may not be exactly sure what variable you want, so we want to be explicit about it. So just go ahead and put that into your table as I'm showing you here. And then we have the value. And here I'm just showing you some examples for age in the first row, which would be the mean and standard deviation. So here what I'm saying is that I want to report patient age in years. I want it to be to one significant digit after the decimal place. And here I'm showing it as it's being presented as 2 digits prior to the decimal. For female, here we're showing you the number and the percent. So here I'm saying we'll have a 1 number summary of the number of females in this study sample, and then we'll show the percent to 1 decimal place. Okay. So again, this is a very straightforward and I think a good way to approach this if you have never done this before is just find a couple papers that are similar to what you think you might be reporting on. Look at how they laid out their tables, right? And if that makes sense to you, then that will provide a pretty good foundation for what your shell tables might look like, right? So then you can begin to put together some empty tables that we will later populate with the actual results. Here is an example of a bivariate table. So if you look, we are looking at the exact same variables we saw in the univariable table. We're looking at age in years, female, distance to the nearest health center, and then we have this variable on sanitation. And now here, instead of laying this out for the whole study sample, we're laying this out by case and control status, right? So these could be for acute rheumatic fever patients versus healthy controls, let's say, or whatever contrast you felt was important. And then essentially all we do is we lay the table out as we have before. So we have the variable label, we have the actual variable. Again, that would just allow us who are conducting the analysis to be able to map those variables back to the actual variables in the REDCap ARC database. And then again, we'll have this split by cases and controls. I always like to provide the number at the top for the actual publications. And then we have this new column for, here it's for a p-value. But again, that could be for whatever statistical summary we may want to include here, and it could be more than one. Most commonly, this would be a p-value. So here I'm showing you, we want to show a p-value and we want to show it to 3 significant digits. There are other summaries we can talk about when the time comes. A standardized mean difference, for instance, could be an alternative. But again, if you go back to look at some papers in your area, you will see plenty of good examples of tables that are laid out just like this. And so what we want to do is think about what variables do we want in our specific tables that we might include in our actual manuscript. And then our last example here is a shell table for a multivariable model. Not all of you will include some type of multivariable regression in your papers. Some of these may look slightly different depending upon the type of model we're actually fitting or the information that we want to convey. But here I'm showing you what's a pretty standard table that you might see for, let's say, a multivariable logistic regression analysis. So for instance, if we want to try to compute an odds ratio for increasing age, for some outcome of interest, let's say it's acute rheumatic fever, then this is how we may attempt to present some of those results. And again, so I'm showing you these same variables in the label column: age, female, distance to nearest health center, and sanitation. Here again, we are mapping the variables, the specific variable names to this table so that we can make that connection as seamless as possible. And then I'm showing you two new categories here. One is for a reference group and one is for a risk group. Now we'll get much more into the details of this when we get to the data analysis module of the webinar series. But here the information we're trying to convey is, which two groups do we want to compare? Which one is going to be our reference group, or let's say our baseline group, and then which group is going to be our risk group. You could think of this kind of as unexposed or exposed, if that's language that you're more familiar with. But this is basically the contrast of interest that we are estimating, right? And then we're summarizing that contrast of interest in this last column here with an adjusted odds ratio and 95% confidence interval. So don't worry if those are terms that you're not familiar with yet. You will be by the fourth web presentation. But again, the main focus here is we're just thinking about what information might we want to convey and how might we lay that out. And as you get to some of these more complex analyses, we are certainly happy to help think about how we can best lay out and convey some of that information. And again, I know I've said it twice before, but if you go back to your papers that are in your area, some of those that you're reviewing for this project, you'll certainly see some tables that are laid out very much as this. And so again, if any questions come up about shell tables, what's the purpose? What am I really trying to do here? By all means, reach out. I'm happy to have any conversations about that and how you can go about putting these together. And now we come to our next step and the steps for you, the ARC investigators. So the next step for you is to actually go out, take the REDCap data dictionary that you've been provided, and identify those variables that you think you will need for your research project, right? So just as we talked about before, what I think would be most helpful is if you went ahead and entered the variable field names exactly as they're provided in the data dictionary into a document, right? This could be a Word document, a text document, an Excel spreadsheet, however you would like to do that, under these four main headings of outcomes, exposures, covariates, and then any other variables that are relevant to your study. And so again, I think if you go back to that PDF document, you look at the field labels, that will provide you a lot of information about those variables that we have available as part of the ARC network database. And then if you can actually get that variable name and then put that into the Excel table or the Word document under these four headings, I think that'll give us a very clear indication and approach to identify those variables of interest. And then once you've done that, you can go ahead and begin to try to make these shell tables that we just presented on. And so you can generate shell tables for your project that include the variable or the field names as an additional column as I showed you. So again, you can always go back to those slides 13 to 15, get a feel for what those tables might look like, and then how we might want to lay those out, again with the column including the variable label that you'll actually see in the published paper, and then that additional column that shows us the REDCap data dictionary variable name that we'll be able to go back and map those data elements to. And then once you've got that all together, those can be submitted via email to the ARC Diagnostic Network email. So I've mentioned this a few times already, but I just did want to re-emphasize that if you have any questions about what was discussed in this webinar or what the expectations are of you as an investigator in terms of putting together and identifying these data elements and these shell tables, please reach out to us at the ARC Diagnostic Network email. We'll be happy to field those questions and be in touch and to help in any way that we can. And in addition, if there's anything that we could have presented differently or more clear, or you have any questions or comments that may help us improve future webinars, by all means, please send those to the email above as well. And in closing, I look forward to seeing all of you as soon as possible. And I want to thank you all again for your continued work and contributions to this important endeavor and to the ARC network. Have a great day.